Welcome to my channel. So in this second slot, we're going to discuss chapter 4 periodic table and chapter 5 chemical bonding. Remember, group refers to the vertical column of element in the periodic table and period refers to the horizontal row of element in the periodic table. We try to do this question. So please check what is the basic principle of arranging element in the periodic table. So please remember the elements in the periodic table are arranged according to increasing order of proton number. For example, let's say we want to find the proton number of B, so we try to find the proton number A, 1, 2, 3, 4, 5, 6, 7, 8. The proton number of B is 8. From here we try to do the electron arrangement 2.6. Alright, so please remember elements in the periodic table are arranged according to increasing order of proton number. Alright, so we move to the next question. Please remember group 1 element is known as alkali metals, and these elements from group 1 metal, they form cation with positive 1 charges. For example, lithium 1 positive, sodium 1 positive, and potassium 1 positive. So we try to check their physical properties. They are soft metal, can be cut by using knife. They are gray color, shiny gray color surface, good conductor of heat and electricity, and relatively all group 1 element or alkali metal, they have low melting and boiling point, and these elements must be kept in paraffin to prevent reaction with moist. Alright, so moist means reaction with oxygen and also water vapor from the air. Alright, so next, the element from group 3 until group 12. So I put here 3 until 12 is known as transition metal, and this element have special characteristic. One of the characteristic, they act as catalyst in certain specific reaction. So I'll go for the Arbor process is the production of ammonia, contact process is the production of sulfuric acid, Oswald process is the production of nitric acid. The catalyst used in Arbor process is iron, contact process is vanadium 5 oxide, Oswald process is platinum, and one more hydrogenation process or the production of margarine. Alright, sun saturated fat is converted into saturated fat through hydrogenation in the presence of nickel. So please memorize all these catalysts. Alright, so next, why argon chemically inert? So when we check the periodic table under group 18, so group 18 element is known as inert gases, and this element always exists as monoatomic gases. And please remember all these group 18 element has achieved stable duplet and octet electron arrangement. The element at the first position duplet, the other element all has achieved stable octet electron arrangement. For example, argon, the proton number is 18, so 2.8.8, the electron arrangement. Argon has achieved stable octet electron arrangement. So how to explain this one? The valence shell of argon is fully filled with electrons, so this is 2.8.8, right? And argon has achieved stable octet electron arrangement. Therefore, argon do not accept, share, or donate its valence electron to other element. Right. We move on to the next number 5. 4 special characteristic of transition metal, or 4 special properties or characteristic of transition metal. So please remember transition metal from transition element located from group 3 until group 12. All this is known as transition element. They have some 4 special characteristics. They form colored ion or colored compound. They shows different more than one oxidation number or different oxidation number. They act as catalysts in specific chemical reaction, and also all transition element, they form complex ion. Alright, so we try to check this question. Right, state the special, which of the following correct about the special characteristic of transition metal. So transition metal, they show different oxidation number. They form colored ion or colored compound. Right, and the transition element also, they form complex ion. They act as catalyst in certain specific chemical reaction. Right, so we try to check the number 1 function as catalyst to accelerate the rate of reaction. So can be answer number 1 accepted. So we go for number 2, form ion and compound that are black in color. It should be colored ion. So number 2, we cancel all the number 2. Alright, so we go for number 3, has more than one oxidation number. So this answer also correct. So number 3 also correct. So the answer is B. We check answer number 4 as low melting point and boiling point. Please remember transition metal, they are metal, all exist as metal, so their melting and boiling point is higher. All right, so we move on to the next question. Try to check this question. All right, so an element can form colored compound. Okay, which of the following shows the position of element in the periodic table? So please choose the element from group 3 to 12, which is known as transition metal. Their special characteristic, they can form colored ion or colored compound. So the answer will be C. All right, so we move on to the next part. At question number 6, which element are more reactive? So in group 1. So please remember group 1 element is known as alkali metal. When going down the group 1, the reactivity. Alright, so please write down in the module the reactivity will increases, and also please remember electropositivity also will increases. Electropositivity means the tendency of an element to donate its valence electron and form positively charged ion. All right, so how to compare which one has more more reactive or more electropositive? So we check the size. The atomic size of C is smaller, while the atomic size of G is bigger. When the atomic size of G is bigger, the distance between nucleus and its valence electron getting further apart. Thus, the forces of attraction, nucleus forces of attraction towards its valence electron become weaker, here become stronger. Alright, so thus element G can easily donate its valence electron to achieve stable octet electron arrangement. Therefore, G is more reactive than atom C. So I put here atom G is more reactive than atom C. So how to explain this one? So atom G is more reactive than atom C. Atomic size of atom G is bigger than atom C. Alright, so the attraction forces between nucleus and valence electron of atom G is weaker than the atom C. Alright, so thus G easily donate its valence electron and achieve stable octet electron arrangement compared to atom C. Alright, so we move on to the next question. Question number, which element in group 17 is more reactive? So please remember group 17 element is known as halogen, and when going down the group 17, please remember reactivity. Reactivity decreases. And one more, please remember electronegativity also will decreases. The tendency of an element to accept electron and form negatively charged ion decreases also. Alright, so please remember electronegativity also decreases. The tendency of an element to accept electron and form negatively charged ion also decreases. Alright, so we try to answer why. So when the atomic size of R is smaller and the atomic size of S is bigger. So when the atomic size of R is smaller, alright, so the forces of attraction of element R, nucleus of element R towards its valence electron getting stronger. When it's getting stronger, thus R has higher strength to accept electron into its valence shell and achieve stable octet electron arrangement compared to atom S. Therefore, from here R is more reactive than S. Alright, so how to explain this one? Atom R is more reactive than atom S. Atomic size of R is smaller than atom S. Therefore, the forces of attraction between the nucleus and the valence electrons of atom R is stronger than atom S. Thus, atom R has higher strength to accept electron into its valence shell to achieve stable octet electron arrangement compared to atom S. Therefore, R is more reactive than atom S. Alright, so we move on to the next question. Look at the period 3 element. Alright, element in the period 3 is arranged because they have 3 shells filled with electron. So this is period 1, this is period 2, this is period 3. When going across the period 3, when going across the atom period 3, the atomic size or atomic radius, please remember, decreases. So the atomic size of C is bigger, the atomic size of E is smaller. Why? Because when we see the proton number of C, it has 11 proton number, E is 15. So when we check the nucleus. Inside the nucleus of atom C, it has 11 proton. Inside the nucleus of atom E, it has positive 15 proton. Alright, so the number of proton, when the number of protons that present in the nucleus of an atom is higher, the nucleus has stronger forces of attraction to pull all the electron shell towards the nucleus, and this will causes the atomic size become smaller. Alright, so we try to answer this question. Alright, so how to explain the atomic size of E is smaller than the atomic size of C. Alright, the number of proton in atom E is more than atom C. When the number of proton is more, the number of positive charges in the nucleus of atom E is higher or more than in atom C. Forces of attraction between nucleus and electron shell of atom E is stronger than atom C. Thus, electron shell of atom E will be pulled closer towards the nucleus, causing the atomic size become smaller compared to atom C. Alright, so to check question number 9, write the balanced chemical equation for the group 1 element. Please remember all group 1 element can react with halogen, they can react with water, and also they can react with oxygen. Alright, so we check the first one, sodium react with water to produce sodium hydroxide and hydrogen gas. So please practice with potassium react with water. So we take out the potassium ion, we break hydrogen and we break hydroxide. During chemical reaction, the potassium ion join with hydroxide ion, so we will get potassium hydroxide. So we erase these, so we check the hydrogen ion. When single, we make it hydrogen gas. How to balance this equation? So in front of potassium hydroxide, alright, so we try to put 2, then potassium 2, oxygen 2, oxygen will be 2, hydrogen 2 plus 2, 4, hydrogen 4. Alright, so try to do more practice on this part. So we move on to the next one. When potassium react with oxygen, we will get potassium oxide. I'll practice with the another one, sodium react with oxygen. So what product we will get? We take out the sodium ion, we take out the oxide ion. During chemical reaction, we will get sodium oxide. We take the 2, put at the bottom of sodium. And how to balance this equation? So please remember to balance oxygen year 2, year 1. So I put 2 in front of sodium. So now oxygen 2. Alright, sodium 4. If we take the product, this product is known as white solid. When this white solid dissolve in water, so we take the sodium oxide, dissolve in water, we try to get the chemical equation. We take out the sodium ion, we take out the oxide ion, we break the hydrogen ion and hydroxide ion from water. During chemical reaction, so we will get sodium hydroxide, and this one will join, we will get water. And please always remember, when writing a chemical equation, we should get A plus B, we will get C plus D. Alright, so if we get A plus B and the B is keep repeating at the product, please erase the B. Alright, so we try to check here. So here this is B is repeated at the product, so we erase the B. Alright, so and try to balance the chemical equation. So how to balance the chemical equation? I put in front of sodium 2. Alright, so here sodium 2, oxygen 1 plus 1, 2, so oxygen 2, hydrogen 2, hydrogen 2. So please try to practice more on this part. So we move on to the next one, lithium react with chlorine. So try to practice this equation. Alright, so I'll go for the group 17 element is known as halogen. This group 17 halogen exists as diatomic molecule. So when writing the formula, please put Cl2Br2. Alright, Cl2. I try to practice this one. I try to practice chlorine react with sodium hydroxide. So we take another example, bromine react with sodium hydroxide. So what product we will get? Take 2. So here put 2. I take 1 sodium hydroxide. I take another sodium hydroxide. During chemical reaction, so this hydroxide will ionize and produce OH, and here sodium, and here we break the hydrogen, we bring down the hydrogen. We bring down the hydrogen and we bring down the NaO. So we break the Br and we take the Br. Right. So please remember, hydroxide join with hydrogen. So one product that we will get is water. So we remove the hydroxide. Right. So next one, sodium will join with bromide. So we will get sodium bromide. And this one will join with NaO, form sodium hypobromide. Alright, but so please remember, iron with chlorine we will get iron 3 chloride. So please remember this iron, we have 2 type of ion. So number 1 is known as Fe2 positive, which is green color ion, and another one Fe3 positive, which is brown color ion. Alright, so when iron react with chlorines, the product that form is brown color product. Alright, so therefore we take iron 3 ion and chloride ion. During chemical reaction, iron 3 ion will combine with chloride ion, form FeCl. We take the 3, we put here. And how to balance the chemical equation? Balance the chloride 2 and 3. So we make it 2 times 3, 6. 3 times 2, 6. Iron 2, iron 2. Alright, so the name of the product form is iron 3 chloride. Move on to the next question. Question number 11. Answer the question based on the diagram below. Alright, so these two elements from group 1, this is group 2, and from group 3 until 12 is known as transition metal. All right, and this element from group 13, please circle this one. This one can form amphoteric oxide and react with oxygen. This is group 18 element exists as monoatomic gases, and this is group 17 element exists as diatomic molecule. All right, so we try to check the first question, which element exists as monoatomic gases. So please choose element from group 18, so which is B. All right, so next one, which element exists as diatomic molecule. So please choose the element from group 17, which is F. All right. Right, I go for question number 3. Write down the electron arrangement of element C and state its position in the periodic table. So the element C is here. So we try to write down the proton number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So C will be 11. So that will be 2.8.1. So we already answered the electron arrangement. And when the valence electron 1, so we put group 1. And we have total 1, 2, 3 number. So that means element C belongs to period 3. All right, so we move on to the next question. Which element chemically unreactive? Chemically unreactive, please choose the element from group 18. So please choose the element from group 18, element B. Why? Because here duplet the other element achieve octet. Element B has achieved stable octet electron arrangement. Alright, so next one, which element react with oxygen and form amphoteric oxide? Please remember amphoteric oxide, aluminum oxide, the oxide that can react with both acid and alkali is known as amphoteric oxide. And please remember aluminum from group 13 period 3. So where is group 13? So the group 13 is here, period 1, period 2, period 3. So the element will be X. All right, so next question number 6, element C react with water. So the formula of water H2O. Element C belongs to group 1. Group 1. React with water, form colorless solution and release gas. Write down the chemical equation. So I represent the element C. I represent the element C with sodium. So we take sodium, react with water. So what product we will get? So we put here sodium ion. We take out the hydrogen ion. We take out the hydroxide ion. During chemical reaction, the sodium ion will combine with hydroxide ion will form sodium hydroxide. When hydrogen single, we make it hydrogen gas. Next, we try to balance the equation. How to balance the equation? So in front of sodium hydroxide, I put 2. Then I balance sodium 2, sodium 2. Next, I balance oxygen 2, oxygen 2. Alright, so the hydrogen here 2 plus 2, 4, hydrogen 4. Alright, so next what I do, I replace all the sodium with C. Right, so here they give C, so element C. So I erase the sodium, I replace with C. I erase the sodium, I replace with C. So this is the answer given. Alright, so this is the answer student should write. Alright, and please remember this solution is alkaline solution. When we put red litmus paper, it will turn to blue color. Alright, so next question, state the observation when red litmus paper is placed into the colorless solution, the red litmus paper turns into blue. Alright, question number 7. Try to read question number 7. Arrange the element in the periodic table according to increasing order of atomic size from smaller size to the bigger size. How to do this one? From here we go up and go to the right hand side. This is the smallest atom. Alright, so B will be smallest atom. Alright, from here we go down, we go here, we go to the left hand side, this will be the biggest atom. So the biggest atom will be G. Alright, so now we try to find the next one, we go this way, the second one will be A. And we come this way, so we find the F. F will be E. Alright, so next will be D. Alright, X. Alright, so X, then we go for C. C, then we come down here, H. Alright, H, and the biggest atom will be G. Alright, so we try to do one question here. This question shows the diagram consisting of element P, Q, R, S, T. Arrange the element according based on the increasing order of atomic radius. So we go up, we go to the right hand side. This is the smallest. So we go down, we go this way. This is the biggest. Alright, so T is the smallest. Next we go this way, R is second. Then we go this way, S. Then we go check this one, Q, and the P is bigger. So the answer will be A. Alright, we move on to this question. So when oxygen O2 react with substance X, so this is reaction of group 1 alkali metal with oxygen. So take lithium. lithium react with oxygen, so the product we will get lithium ion, oxide ion. During chemical reaction they join, so we will get lithium. All right, so we put here lithium oxide. So to balance this equation, all right, so we balance oxygen here, so oxygen here, so oxygen at the left hand side is 2, here 1, so I put 2, make it oxygen 2, lithium 4, lithium 4. All right, and the reaction is completed, the white solid is formed. Name the white solid, so the white solid will be lithium oxide. All right, so we move on to the next question. Check this question. Which of the following is the position of element M? So element M, so its first shell got 2 electron, second shell got 8 electron, so 8 electron, and the valence shell got 2 electron. So element M from group 2. All right, so when valence electron to group 2, element M from period we have 1 2 3 numbers, so period 3, so group 2 period 3, so the answer will be B. All right, so on to the next question. Okay, which of the following can form M4 ferric oxide? Please remember M4 ferric oxide, the oxide that can react with both acid and alkali, so aluminium. And please remember this aluminium belongs to group 13. Group 13 period will be 3. So where is group 13? This is group 12. So this is group 13. Period 1, period 2, period 3. So we go this way. So the answer will be R. Alright, so we move on to the next part. Okay, student, we're trying to do one essay question. Look at the question diagram below shows the standard representation of lithium and nitrogen atoms. So here lithium atom, the proton number is 3, so 2.1, and the nitrogen atom, the proton number is 7, so 2.5. Alright, so this lithium atom belongs to group. Alright, so please remember group 1 and it has 2 numbers, so therefore it belongs to period 2. Alright, so nitrogen atom has 5 valence electron, therefore it belongs to group 15. Alright, and it has total 2 number 1 and 2, so it belongs to period 2. Alright, so we try to check the question based on the diagram, explain the position of lithium and nitrogen in the periodic table. Alright, so the electron arrangement of lithium is 2.1 and the nitrogen atom is 2.5. Both lithium and nitrogen atom, they have 2 shells filled with electron. Please put filled with electron, therefore lithium and nitrogen belongs to period 2. Alright, so the number of valence electron in lithium is 1, thus lithium belongs to group 1. The number of valence electron in nitrogen is 5, therefore nitrogen atom belongs to group 15. Alright, so and we move on to the next question. Diagram below shows the experiment setup for the reaction between sodium. So I put here sodium react with chlorine, so please write down chlorine exists as diatomic molecule. Please don't write like this, so please put Cl2. Alright, so and when both these react, it will form sodium chloride. How to balance the equation? So chlorine 2, so here I put 2, so chlorine 2, sodium 2, sodium 2, so we will get white color solid. We try to check the first question, state the observation, so I present the answer in the table form. Observation: sodium burns vigorously with yellow flame and produce white color powder. Write down the chemical equation, write the balanced chemical equation, so we take sodium react with chlorine, we will get sodium chloride. Make sure the equation is balanced. Alright, so next we try to get the information given. 5.85 gram of compound, that means this is belong to sodium chloride. Compound is formed, they want the mass of sodium produced in used in this experiment, so I convert this into number of moles. So first step, we find number of moles of sodium chloride. How to find the number of mole of sodium chloride? We take mass over molar mass. So the mass is given is 5.85 and the molar mass of sodium chloride, so please remember sodium 23 plus 35.5 already given here. Alright, so we will get the answer 0.1 mole. Alright, so next we try to check the equation. The information we have is sodium chloride. We need to find the mass of sodium. Therefore, we try to do the ratio mole from the equation. 2 mole of sodium. Sodium is produce 2 mole of sodium chloride. I write down the information given in the equation. Alright, so we try to check this one. So we put here 0.1 mole of sodium chloride is produced from 0.1 mole of sodium. Alright, so now we already get the 0.1 mole of sodium. Alright, so next step, we try to find the mass of sodium. How to find the mass of sodium? We take the number of mole, we times with molar mass. The number of mole is 0.1 the molar mass of sodium is 23. So the answer 2.3 grams. So please practice and do more question. All right, so we move on to the next question. All right, try to check this question. The electron arrangement of atom Q. Atom Q, the electron arrangement is 2.8. So this means the atom Q is belongs to group 17. When writing the formula of atom Q, please write Q2. Identify the period of element Q. Explain your answer. So the electron arrangement is 2.8.7. It has 1, 2, 3 number. Therefore, it belongs to period 3. Why? Because atom Q has 3 shells filled with electron. Alright, so next we try to draw the electron atomic structure of atom Q. So we put P, E, and total proton 17 proton, electron 17 because atom neutral, total number of proton and electron is same. So neutron will be 18 neutron. Right. So I draw the nucleus. So inside the nucleus I put 17 proton, 18 neutron. So first shell, second shell, and valence shell. The first shell I put 2 electron. Second shell I put 8 electron. Alright, so the valence shell, it has 7 valence electron. Alright, so the electron arrangement is given in the question. Alright, so we move on to the next question. Alright, formula of ion Q. And please remember Q, the electron arrangement 2.8.7. When we check the valence electron 7, Q is non-metal. And please remember non-metal will accept electron and form an ion, negative ion. So we put the Q symbol with negative charges. And how many electron will be accepted? We take the valence electron 7. It will accept 1 electron to achieve stable octet electron arrangement. Therefore, we take the 1 we put here. So 1 no need to put. So the formula of the ion is Q negative given in the question. Right. So we move on to the next question. Question number 4. Write down the chemical equation for the reaction element Q react with sodium hydroxide. I do Q. Q represent with Cl. Alright. So I take the Cl when Cl must put diatomic molecule react with sodium hydroxide. So I put here sodium hydroxide. Alright, so when chlorine react with sodium hydroxide, please put 2 here. We take 1 sodium hydroxide. We take another sodium hydroxide. So during chemical reaction, here we take out the hydroxide. So we put hydroxide and we take out the sodium, we put here. Alright, here we take the hydrogen. So we take the hydrogen and we take NaO. So we break the Cl, we break the Cl. So the hydroxide and hydrogen will combine together, will give us water. Alright, so we erase this one. Alright, then next please check this. Na will join with Cl, so we will get sodium chloride. This one will join here, so we will get sodium hypochlorite. Okay, salt. Alright, so now how to get the complete the equation. So how to get the answer? I replace the chloride with Q. So I erase the chloride, I put Q. I erase the chloride, I put Q. I erase the chloride, I put the symbol given in the question. So this is the answer. Please practice and do more question. Right. So next we go for if the reaction is repeated by using element R. So I put element R here. Element R located below element Q. So element Q at the top of group 17. So this element belongs to group 17, and please remember when going down the group 17, the reactivity will decreases. In the another case, this one Q will be more reactive. R will be less reactive. Alright, so we try to answer this question. Alright, compare the reactivity of element R and Q. So we put element Q is more reactive than element R. Alright, so why this? We try to explain the atomic size of Q is smaller, atomic size of R is bigger. So the first point, the atomic size of Q is smaller than R. Alright, when atomic size is smaller, the attraction, the forces of attraction between nucleus and the valence electron of atom Q is stronger than atom R. Thus, atom Q has higher strength to accept electron into its valence shell to achieve stable octet electron arrangement compared to atom R. Alright, so we move on to the next question, Q. Alright, so Q react with water. So we put water here, H2O, and we try to answer this question. If let's say I represent Q with chloride. Alright, so I put here Cl2, must put Cl2, react with water. So what product we will get? We take out the, break the chloride here, we break the chloride. Right, water we break like this, OH, we cancel this, we put HO. During chemical reaction, HCl. Alright, and this one will join here, we will get hypochlorous acid. Alright, so we erase everything. Right, now we try to replace the chloride with Q. So I erase all chloride, I put Q. I erase all the chloride, I put Q. I erase all the chloride, I put Q. So this is the answer, and this is the answer given. And please remember, this is strong bleaching agent. So when we put blue litmus paper, it will turn to red. It will turn to red, and it will be turned to white color. So what can be observed when a blue litmus paper is put into the product form? The blue litmus paper turn red and then white. All right, so try to do more question and we move on to the next part. On to the next question, experiment to determine the reactivity of group 1 alkali metal towards water. And please remember reactivity of group 1. Alright, so I put here group 1 metal, lithium, sodium, potassium. When going down the group 1, the reactivity increases. In this case, potassium is more reactive towards water than sodium and lithium. Alright, so we try to check the question. So read the question. Metal X is more reactive towards water than metal Y. So that means I'll take the metal X is potassium, metal Y is sodium. So here alkali metal, so they place on the surface of water and we check the reactivity of metal. And we try to read the question from the above statement. We need to suggest metal X, which is potassium, and metal Y, which is sodium. So I suggest metal X is potassium, metal Y is sodium. And give me the procedure, tabulation of data, observation, and finally we have to make a conclusion. So the procedure, we cut sodium into small piece by using knife. And procedure number 2, use filter paper to absorb paraffin oil from the surface of sodium, and we drop the sodium carefully onto the surface of water, okay, in the glass straw using forceps, and we record the observation. And the solution that form is alkaline, therefore we test with the red litmus paper, and we repeat step 1 until step 5 using potassium to replace sodium. And the data we need to put in the table. So sodium is moved quickly on the surface of water, producing etching sound, and a colorless solution which turns the red litmus paper into blue is formed. Potassium move very quickly and randomly with purplish color flame. Alright, purplish color flame on the surface of water and producing etching sound, and also pop sound is heard. A colorless solution which turns the red litmus paper into blue is formed. And finally we go for conclusion. The conclusion, potassium is more reactive towards water than sodium. We try to check this question. Alright, so when lithium react with water, so I'll take lithium react with water. So we break water, hydrogen ion and hydroxide ion, lithium Li positive. Alright, so during chemical reaction, lithium hydroxide will form. Lithium hydroxide, when we see hydrogen, so we make it hydrogen gas. Alright, so how to balance this equation? So in front of the lithium hydroxide, we put 2 here, we balance lithium 2, lithium 2. Next, we balance the oxygen. Oxygen 2, so I put 2 oxygen. Right, so hydrogen 4, hydrogen 2 plus 2, 4. And please remember the solution that form is lithium hydroxide, and this solution is alkaline solution. It will turn the red litmus paper into blue. Alright, so we check the question, which of the following describe the properties of the solution form? The solution that form is lithium hydroxide, and this solution is alkaline solution. And this solution turns the red litmus paper into blue, so therefore the answer A. We try to check the second B, answer B, no visible change on the color of blue litmus paper. So this answer wrong. So this answer is wrong. So the blue litmus paper turns red, wrong. Alright, so no visible change in the color of red litmus paper, wrong. So the answer A. Alright, so we move on to the next. We move on to the chapter 5, chemical bonding. So under chemical bonding, please remember the first point, the physical properties of ionic compound. This ionic compound is formed between metal, alright, plus non-metal. Non-metal via transferring of valence electron. And the type of particles present, please remember ion. And the physical properties of ionic compound, all ionic compounds soluble in water but insoluble in organic solvent, and they have high melting and boiling point due to the stronger, please remember, due to the stronger electrostatic forces of attraction between the cation and anion that present in the ionic bonding. Alright, so and conduct electricity in molten and aqueous state, but cannot conduct electricity in solid state, because in molten and aqueous state there is a freely move ion which able to conduct electricity. In solid state, the ions unable to move freely and therefore they cannot conduct electricity. We try to check this question. All right, which of the following state the properties of ionic compound? The properties of ionic compound, they dissolve, exist as gas, so this will be wrong. Next one, they dissolve in organic solvent. Please remember, ionic compound soluble in water but insoluble in organic solvent. All right, so next one, cannot conduct electricity. Please remember, ionic compound can conduct electricity in molten and also in aqueous, not in solid. Solid cannot conduct electricity. All the ionic compound has high melting and boiling point, so the suitable answer is D. All right, so we move on to the next properties of covalent compound. The X are physical properties of covalent compound, and please remember, covalent compound, the formation is between non-metal plus non-metal. We are sharing of valence electron between the non-metal atoms. And the physical properties of covalent compound, they are insoluble in water but soluble in organic solvent. And the F accept, please remember, acid that made up of hydrochloric acid, sulfuric acid, nitric acid. This acid can dissolve in water and also in organic solvent. When they dissolve in water, they ionize to produce hydrogen ion. And one more, please remember, ammonia. Ammonia can dissolve. Ammonia NH3, they can dissolve in water to produce hydroxide ion. Alright, so please remember, next one, they have low melting and boiling point due to the weaker van der Waals forces of attraction that exist between the molecule of covalent, thus lower heat energy required to overcome the forces of attraction. And please remember, all covalent compound exist as neutral molecule. There is no freely moving ions to conduct the electrical charges. Therefore, the ion covalent compound do not conduct electricity. We move on to this question. Try to check when they are sharing electron. This is a covalent bond, and the compound form here is carbon dioxide. Please remember, carbon dioxide and oxygen is made up of double covalent bond. All right, so state one properties of the compound, physical properties of this compound. So this compound insoluble in water but soluble. All right, soluble in organic solvent. They do not conduct electricity and they have low melting and boiling point. All right, so we move on to the next question. All right, so check the next question. Question number 3. Explain why sodium chloride in solid state. When sodium chloride in solid state is made up of chloride ion and sodium ion, in solid states the ion unable to move freely. Therefore, they cannot conduct electricity. But in aqueous or liquid state, the ion able to move freely and conduct electricity. So we need to explain sodium chloride is an ionic compound. In solid state, the sodium ion and chloride ion are held together or attracted together by stronger electrostatic forces of attraction in lactic structure. The ions are fixed at the position and do not move freely. Hence, ionic compound in solid state do not conduct electricity. However, in aqueous or molten, the ions are freely move. Therefore, they can conduct electricity. All right, so we move on to the next question. When they give two different type of compound, one is molten lead to bromide. Please remember, lead to bromide, molten or molten aluminum oxide. All these is made up of ionic compound. They can conduct electricity. Naphthalene C10H8. So I put here C10H8 is made up of non-metal plus non-metal. They exist as neutral molecule. Therefore, there is no freely moving ion to conduct electricity. So for this ammeter needle will deflect and shows reading for molten. When we repeat the experiment by using molten naphthalene, the ammeter needle do not deflect and shows the reading. So how to explain the answer? Lead to bromide made up of ionic compound and exists as ion. In molten state, the lead to ion and bromide ion are able to move freely and conduct electricity. Naphthalene is a covalent compound and made up of neutral covalent molecule. In molten state, there is no freely moving ion to conduct electricity. Therefore, naphthalene do not conduct electricity in solid or in liquid state. Dear students, so we try to check the formation of ionic compound and the type of particles present, forces of attraction in the formation of ionic bonding. Alright, so the formation of ionic bonding occur between metal plus non-metal atom. And please remember, metal atom from group 1 until group 13, or they have valence electron 1, 2 or 3. And please remember, non-metal atom, they from group All right, so group 14 until group 17, all they have valence electron of 4, 5, 6, and 7. All right, so the formation of ionic bonding occur via transferring of valence electron from metal atom to non-metal atom. So the metal atom will form cation and the non-metal atom will form an ion. All right, so the type of particles present is ion. The forces of attraction between exists between n cation and anion is known as electrostatic forces of attraction. We try to check the first formation of ionic compound when they give sodium combined with oxide atom, and this name of this atom, please remember, oxide atom. All right, so when we try to do the electron arrangement 2.8.1, when we see valence electron 1, please remember this metal will form cation by donating its valence electron. So we put sodium positive, we take the 1 we put here, and the electron arrangement is 2.8. Sodium ion has achieved stable octet electron arrangement, and we check the oxide atom 2.6, and this oxide atom has valence. Therefore, this oxide atom is non-metal atom and it form an ion, negative ion. So we put O negative, we check the valence electron, we take the valence electron 6, it will accept 2, it will achieve stable octet electron arrangement. We take the 2, we put in front of the oxide ion. So the formation of ion is O2 negative, and this oxide ion has achieved stable octet electron arrangement. There is a stronger forces of attraction, electrostatic forces of attraction will attract both ion combined together and form sodium oxide. So we combine this together and we take the charge 2 we put at the bottom of sodium. So this is the formula of the ionic compound, and from this formula we check the sodium ion. We have 2 sodium ion. All right, we check the formula, we have 2 sodium ion, and each sodium ion has achieved stable octet electron arrangement, which is 2.8, and we have 1 oxide ion, the electron arrangement 2.8. And how to draw the electron arrangement of the compound form? So I take the 2 I put here, and I open bracket, I write down the symbol of sodium. So first shell, second shell. The first shell, it has 2 electrons, so I put 2 electron. Second shell, 8 electron. Alright, so and I close the bracket, I take the charge, I put here. Alright, so then I open the bracket. Alright, so I take the symbol of oxygen, I put here. Oxygen has 2 shell, so first shell, second shell, and I close the bracket, I take the charge 2 negative, I put here. Alright, so we use different symbols. So here I use X symbol 2.6. Alright, it has 2.6 valence electron, and oxygen accept 2 electron. We check here 2 negative, so we put 2 dot here. Right, so that's how we draw the electron arrangement of the compound form, and we try to do the assay question for the formation of sodium oxide. Sodium atom with electron arrangement 2.8.1, the sodium atom will donate 1 valence electron to achieve stable octet electron arrangement, which is 2.8. A positive ion of Na positive or sodium ion is formed. Oxide atom has electron arrangement 2.6. Oxide atom receive 2 electron. We check here 2 electron from 2 sodium atom. From 2 sodium atom to achieve stable octet electron arrangement, a negative ion of O2 negative is formed. The sodium ion and oxide ion are attracted together by stronger electrostatic forces of attraction, forming ionic bonding. And please mention the formula Na2O. Alright, so that's how we write down the assay question. We check this question, we try to them. 5.1 shows the electron arrangement of sodium chloride compound. When we see electron arrangement like this, so please remember this is ionic bonding. Okay, the formation of bonding is ionic bonding. So we take the sodium atom, we put here the first shell 2 electrons, I put for 2 electron. Second shell, all right, so we have 8 electron. This is atom, please remember here we take 1, so we put 1. All right, so the electron arrangement of sodium atom is 2.8.1. This atom will donate 1 valence electron and form sodium ion. All right, so now we check here, we have chloride ion, so the charge is -1, so we take the chloride atom here. All right, so we check the first shell 2 electron, the second shell we have 8 electron, and the valence shell we have 8 electron, so 8, so we -1, so we will get 7. So the electron arrangement of chloride atom is 2.8.7. This chloride atom is non-metal, and therefore it will accept 1 electron from sodium atom. All right, so we check the question, state the type of bonding form. The type of bonding form is ionic bonding. Don't write ionic compound here, they ask bonding. All right, so next, how sodium ion and sodium chloride form from their respective atoms. So we put here sodium atom with electron arrangement. The electron arrangement 2.8.1 will donate one valence electron to chloride atom. All right, so next point, chloride atom with electron arrangement 2.8.7 will accept one electron from sodium atom. So that's how we answer this question. So we move on to the next question. Look at this question. So this question shows the position of element X and Y in the periodic table. So we try to check this is group 1, this is group 2. All right, so element X from group 2. Right, so we put here group 2, and please remember group 2 element is known as metal. They will donate two valence electrons, so X will form two positive ion. All right, so here group 13, 14, 15, 16, 17. So Y from group, all right, group 17. So it has valence electron of 7. It will accept one electron and form an ion. And please remember, this is known as non-metal atom. Non-metal atom will accept one electron and form negative ion. So we put here negative, we take the one, we put here. So one, no need to put. And we write down the formula of the compound form. So I put here X, Y. We take the 2, we put at the bottom of Y. All right, so the formula will be B. Answer will be XY2. All right, so we move on to the next part, the formation of covalent bond. So type of bonding and the forces exist between the covalent bonding. So please remember, covalent bond is formed between non-metal plus non-metal, and please remember groups 14 until group 17 is non-metal, or valence electron of 4, 5, 6, 7 is non-metal. All right, so the covalent bond formed by sharing valence electron between non-metal atoms. The type of particle is molecule, and the forces exist between the molecule is van der Waals forces of attraction. And we try to check the question number 6, explain the formation of covalent bond between carbon atom and chlorine atom. We check the electron arrangement of carbon atom 2.4 when the valence electron 4. Please remember, carbon is non-metal. And we check the electron arrangement of chloride atom 2.8.7 when the valence electron 7. Chloride also non-metal, and type of bonding form is covalent bond. And how to get the formula? So please check, the carbon got 4 valence electron. It need 4 more valence electron to achieve stable octet electron arrangement. Therefore carbon will contribute 4 electron for sharing. All right, so chloride has 7 valence electron. It need 1 electron, okay, to achieve stable octet electron arrangement. Therefore chloride will contribute 1 electron for sharing. And we try to do crossing here for here. All right, 1 here. So the formula that we will get is C1 chloride is 4. All right, so and how to draw? So please check my previous video. Okay, in that video I got described how to draw this electron arrangement. All right, so now we go for the formation of tetrachloromethane. These are the compound that form is known as tetrachloromethane compound. And we try to check the formation of tetrachloromethane. Carbon atom has electron arrangement of 2.4. Chloride atom has electron arrangement of 2.8.7. And we can put here carbon need 4. All right, 4 electrons, all right, to achieve stable octet electron arrangement. And we can put here chloride need one electron to achieve 1 electron to achieve stable octet electron arrangement. All right, so one carbon atom contribute 4 valence electron. It will contribute 4 valence electron to how many chloride atom? To 4 chloride atom. All right, so next, one chloride atom will contribute 1 electron each. So one chloride atom will contribute 1 valence electron each to carbon atom. And we try to check here, they will share how many pairs of valence electron? One carbon atom, they share a pair, okay, 2 pairs, 3 pairs, and 4 pairs of valence electron with 4 chloride atom and form 4 single covalent bond. All right, so all carbon atom and chloride atom has achieved stable octet electron arrangement. Therefore a covalent bond compound, or we can put a covalent bond, all right, or covalent compound with the formula CCl4 is formed. All right, so that's how we write the answer for the essay question. We try to check this one, which of the following substance is made up of covalent compound? We write the formula aluminium oxide. Please remember, aluminium metal and oxide is non-metal, so the type of bonding form is ionic bonding. And copper to sulfate, so copper metal and sulfate is non-metal, type of bonding is ionic bonding. Naphthalene C10H8, so the carbon is non-metal, hydrogen non-metal, the type of bonding form form is covalent. Magnesium chloride, so metal non-metal type of bonding form is ionic, so the answer C. All right, so which of the following is correct about the covalent bond? Covalent bond form involving all the electron in the atom. Please remember, it's only involve valence electron. Covalent bond is a type of chemical bond. All right, so this accepted. So we try to check the next question. Covalent bond form because atom want to release electron? No, they will share the valence electron. Covalent bond form by when transfer or share electrons occur. So this also is wrong. So the answer is B. All right, so we move on to the next question. We try to check the electron arrangement of G is 1. So please remember G electron arrangement is 1, and please remember G is hydrogen atom, and the electron arrangement of J is 8, so 2.6. All right, so how to get the formula? Please remember G is as one valence electron, and it need one more electron to achieve stable duplet electron arrangement. And this J, it has 6 valence electrons, so therefore this is non-metal. It need 2 more electron to achieve stable octet electron arrangement. Therefore the formula that we will get, we do crossing here, 2 and 1. So G will be 2, J will be 1. So the answer is B. All right, so we try to check this question. All right, so describe the formation of chemical bonding between carbon atom and oxide atom and draw the electron arrangement of this compound. So this is a type of essay question I try to do here. So we try to check the carbon as proton number 6. So I do 2.4. All right, carbon 2.4. All right, oxygen, oxide atom, it has proton number is 8. So we do the electron arrangement 2.6. All right, so when 4 is non-metal, all right, non-metal, and this also non-metal, the type of bonding form is covalent bond. So we try to check carbon will contribute how many electron for sharing? 4. All right, so to achieve stable octet electron arrangement, oxide need 2 more electron to achieve. Here we got 6. It need 2 more electron to achieve stable octet electron arrangement. Therefore oxide will contribute 2 electron for sharing. So we do crossing like this. 4 will be here, 2 will be here. So the formula carbon 2 oxygen 4, we can simplify this as 1 2. So the formula CO2. All right, so from this formula we already know carbon is 1 and oxide is 2. Okay, they are sharing valence electron to form covalent bonding. So this is the formula, and we try to draw first, then only draw the electron arrangement of the compound, then only we try to describe the formation of carbon dioxide molecule. All right, so we try to check the carbon. We have 1. All right, so we check the electron arrangement. Carbon as 2 shell, and 4 electron, and I put the first shell. All right, so here the first shell I put 2 electron. All right, so and oxygen got 2 oxygen atoms, so I put 1 oxygen atom here, another oxygen atom here, and we try to check the electron arrangement. It has 2 shell, so oxygen here first shell, the second shell I put inside. All right, so first shell, the second shell is put inside. All right, so please remember the first shell of oxide got 2 electrons, so I use different symbol like this. All right, I put different symbol like this. All right, and we circle this. All right, so here we put this one, we put inside the sharing shell between the carbon and oxygen. Where's the inside the sharing cell? Here. All right, this is the inside the sharing cell. We put 2. All right, so I put 2 electron from one oxide, here 2 electron from another oxide, and we try to do here outside the shell, outside the valence shell, we take the 6, we minus with 2, 6 minus with 2, we put 4. Outside we put 4, so 1 2 3 4, 1 2 3 4. So next we try to check if carbon oxygen give 2 electron for sharing, carbon also must give 2 electron for sharing, so they will share mutually. So here we put 2, so here we put 2, so carbon contribute 4 electron for sharing, so here 2, total will be 4, and they form 2 double covalent bond. All right, so here they share how many pairs of valence electron? 1 2 3 4. They share 4 pairs of valence electron, form 2 double covalent bond. All right, so by referring to the electron arrangement of this compound, we try to describe the formation of carbon dioxide. So how to describe the formation of carbon dioxide? So I put here electron arrangement of carbon atom is 2.4, and this carbon atom, so I put here carbon atom, the carbon atom needs 4 electrons to achieve stable octet electron arrangement. All right, so next we try to describe about oxide atom. So I put here electron arrangement. The electron arrangement of oxide atom is 2.6, and this oxide atom, okay, so I put here oxide atom, it needs, right, needs two electrons to achieve stable octet electron arrangement. All right, so we move on to the next point. So one carbon, all right, one carbon atom, it will contribute. So we check here, one carbon atom, it will contribute 4 electron for sharing with how many oxide atom? With 2 oxide atom. So we put here one carbon atom, all right, contribute four electrons for what? For sharing with two oxide atoms. All right, so next, oxide atom. All right, so we put here oxide, each oxide atom or two oxide atoms will contribute to two electrons. We put this word each. All right, each for what? For sharing with one carbon atom. All right, so next point, we put here one carbon atom and two oxide atoms, they will share one carbon atom and two oxide atom. They will share how many pairs of valence electron? Please check here, one pair, two pair, three pairs, four pairs of valence electron. They will share four pairs of valence electrons, all right, and share four pairs of valence electron to form double covalent bond. All right, so double covalent bonds, or we can put two double covalent bond. All right, so next point, both carbon and oxide atoms has achieve stable octet electron arrangement. All right, so arrangement. Next point, covalent compound, a covalent compound with formula of CO2 is formed. All right, so then we draw the electron arrangement of the compound to prove the explanation. All right, so that's how we do the essay question. So I read again, the electron arrangement of the carbon is atom is 2.4. Carbon atom need 4 more electrons to achieve stable octet electron arrangement. The electron arrangement of oxide atom is 2.6. Oxide atom needs 2 electrons to achieve stable octet electron arrangement. All right, so one carbon atom contribute 4 electrons for sharing with 2 oxide atoms. So I put here atoms. All right, so next point, 2 oxide atoms will contribute 2 electron each for sharing with one carbon atom. So next point, one carbon atom and two oxide atom, they share 4 pairs of valence electron, form double covalent bonds. All right, so both carbon and oxide atom have achieved stable octet electron arrangement. Therefore, a covalent compound with the formula of CO2 is formed. All right, so we move on to the next question. Right, dear student, we move on to the next type of covalent example of double covalent compounds. So if they ask example of double covalent compound, oxygen and carbon dioxide. If they ask example of triple covalent compound, so please remember the example of triple covalent compound can be seen in nitrogen molecule. All right, so we try to check this question. So by using an example, explain the formation of triple covalent bond, include the electron arrangement of the compound. So please remember, triple covalent compound can be found in where? In nitrogen, N2. All right, so the nitrogen has the 7 proton number, so we do the electron arrangement 2.5. We take another nitrogen atom, so 2.5. All right, so each nitrogen has 5 valence electron. they need 3 more electron to achieve octet. They need 3 more electron to achieve octet. So each nitrogen atom will contribute 3 electron for sharing. So they will share total 3 pairs of valence electron form triple covalent bond. All right. So the formula N2, the formula of the compound form is nitrogen N2. And how to draw the formation of the compound? So I put nitrogen. It has 2 shell. So I put the first shell, second shell. All right. So I put the first shell 2 electrons. So we put here first shell 2 electron, and the another nitrogen atom also has 2 shell. So I put here first shell, the second shell we put inside. All right, the first shell we have 2 electron. All right, so second shell here, this one we put inside. We put inside the sharing. All right, so sharing valence shell. All right, so inside the sharing valence shell of nitrogen atom, I put 1, 2, 3. All right, so outside of the valence shell, we put 5 minus with 3. So 5 minus with 3, so we will get 2. So I put 2 here. All right, so here also same, inside we put 3. So I use 3 different dot 1 x x x. So 3 different electron symbol with x we put inside the sharing cell. Outside, so outside here we put this inside. Outside 5 minus 3 we put 2. So outside I put 2. All right, so this nitrogen atom has achieved stable octet electron arrangement. So please practice. Describe the formation of nitrogen molecule. The formation of triple covalent bond can be explained by using nitrogen molecule. We can put symbol here. Nitrogen atom has electron arrangement 2.5, and we can put here it need 3. Right, 3 electrons to achieve stable octet electron arrangement. All right, so next point, nitrogen atom need 3 more electrons to achieve stable octet electron arrangement. 2 nitrogen atom will contribute 3 electron. We must put each for sharing. All right, so the 2 nitrogen atom, they will share a pair, 2 pair, 3 pairs. 3 pairs of valence electron form triple covalent bond. Both nitrogen atom has achieved stable octet electron arrangement. Thus, a covalent compound with the formula N2 is formed. And try to draw the electron arrangement. So try to practice this one. Look at this question. All right. So we try to do this question. Which of the following molecule share 3 pairs of electron between 2 atoms? So the 3 pairs of electrons stand for the triple. So please remember triple covalent bond. The triple covalent bond can be seen in nitrogen atoms. So the answer will be D. All right. So we move on to the next type of bonding. All right. So next type of bonding is known as dative bonding. So dative is a special type of covalent bond where the sharing pair of valence electron comes from one atom only. All right, so we try to check this question. So try to check this question. A type of covalent bond is a special type of covalent bond. Both share electron come from one atom only. So here they put one atom only. So what is the type of bonding? So answer dative bonding. So we go for the meaning of dative bonding. So state the meaning of dative bonding. Transfer of valence electron. This will be wrong. All right, so next one, the bond form. Okay, when the electron pair share is come from one atom only. So the answer is B. All right, so we check answer number C, a bond involving electrostatic attraction forces between C of electron and positively charged ion. So please remember, when C of electron, this will be metallic bonding be seen. So we check the example of dative bonding. Dative bonding can be seen in H3O positive. This is known as hydroxonium ion, or another one is ammonium ion. All right, so ammonium ion. All right, so please remember, this oxygen atom and nitrogen atom is known as highly electronegative atom, and they have lone pair. Lone pair means unshared pair of valence electron. All right, so here nitrogen with the electron arrangement 2.5. All right, so it contribute 3 electron for sharing with the hydrogen atom, and it has one lone pair, unshared pair of electron. This unshared pair of electron will be shared with hydrogen ion. And please remember, hydrogen ion, all right, do not have electron in the shell. No electron in the valence shell, and it need 2, all right, 2 electrons. Okay, the hydrogen ion need 2 electron to achieve stable duplet electron arrangement. So bonding, so in ammonia molecule, all right, consisting of nitrogen atoms that achieve stable octet electron arrangement, and 3 hydrogen atoms that has achieved stable duplet electron arrangement respectively through formation of covalent bond. We can check here, hydrogen has achieved duplet. duplet and nitrogen as a chief octet through formation of covalent bond. And this nitrogen atom in ammonia molecule as one lone pair or unshared pair of electron. This is the one. This unshared pair of electrons can be shared to the ion that do not have electron in the shell. The example of ion that do not have electron in the shell is hydrogen ion. So we put here hydrogen ion do not have any electron in the shell and need 2 electron to achieve stable duplet electron arrangement. The one unshared pair of electron of nitrogen atom in ammonia molecule that not involved in the formation of covalent bond, which one not involved? So this is the one not involved. All right, will be shared to the hydrogen ion through formation of dative bonding. Thus, ammonium ion with the formula NH4 is formed. In ammonium ion, nitrogen atom and all the four hydrogen atoms has achieved stable duplet octet and duplet electron arrangement respectively. And the Lewis structure that we have to draw to prove the formation of dative bonding is here. Alright, so where is the dative bonding? So we specify the formation of dative bonding here. Try to practice on hydroxonium ion also. Alright, so we move on to the next part. The next question, by using example of the formation of hydrogen bonding, explain the formation of hydrogen bonding, include the diagram to show the formation of hydrogen bonding. Please remember hydrogen bonding formed between the hydrogen atoms that attach to the highly electronegative atom. The highly electronegative atom is known as NOF. N stand for nitrogen atom, O stand for oxide atom or oxygen atom, and F stand for fluoride or fluorine atom. These are the highly electronegative atom, and this high formation of hydrogen bonding can be seen in ammonia molecule, water molecule, and also hydrogen fluoride molecule where we have NOF here. Alright, so how to explain the formation of hydrogen bonding? The formation of hydrogen bonding can be explained by using water molecule or ammonia molecule or hydrogen fluoride molecule. The oxide atom in water molecule, so we have oxide atom here. This oxide atom, please remember, is highly electronegative atom. Alright, so the highly electronegative atom, they have higher tendency to pull the sharing pair of electrons towards them. Alright, so this causes the hydrogen atom that share the valence electron with oxide atom become partial positive and the oxide atom become partial negative. Therefore, the water molecule become dipole molecule. Alright, so next point, how to explain the water molecule consists of two hydrogen atom that shares one pair of valence electron each with highly electronegative atom through formation of covalent bond. The electron pair that shares between hydrogen atom and the oxide atom, which is highly electronegative, will be pulled towards the oxide atom. This causes the hydrogen atom become partial positive charge while the oxide atom become partial negative charge. Thus, the water molecule become dipole molecule. Alright, the attraction forces between the hydrogen atom and the oxide atom of nearby water molecule form the hydrogen bonding. So how to draw? So we draw like this. Alright, so please practice on this part and do more question. Alright, so to check this question, which of the following shows the hydrogen bonding? So please check in the hydrogen formation of hydrogen bonding, we need hydrogen atom. So here we don't have hydrogen atom, and the formation of hydrogen bonding can be seen in water molecule, ammonia molecule, and also hydrogen fluoride molecule, which they are attached to the highly electronegative atom. So highly electronegative atom, please remember NOF. Here we don't have highly electronegative atom. So this oxide atom is known as highly electronegative atom. So the answer will be B. Alright, so we move on to the next question. Alright, next we move on to the metallic bonding. So the formation of metallic bonding can be seen in metal atom from group. Alright, so please remember group 1 until group 13 is metal. So the metal atom. Alright, so how to explain this one? The formation of metallic bonding can be explained in sodium atom. So please remember sodium atom, it has 2.8.1. Alright, this one is disturbing the stability and this atom are arranged closely packed and in order in solid state. So metal mostly exists in what state? Solid state. They can vibrate and rotate, okay, in the solid state. So the second point, sodium atom has electron arrangement 2.8.1, and they exist as solid. All right, so the solid sodium atom in solid state are arranged closely packed in lattice structure. The atom can vibrate and rotate at the fixed position. During vibration and rotation between the atoms, some of the valence electron of sodium atom, so we put some of the valence electron of sodium atom can be delocalized, can move out from the valence shell. All right, this electron will form sea of electron. The delocalized electron will form sea of electron, and the sodium atom become positive ion. All right, so the sodium atom that donate the electron or delocalize the electron become positive ion. The attraction forces between the sea of electron and positively charged ion, which is sodium ion, form metallic bonding. And please remember, the type of attraction forces is known as electrostatic attraction forces between the sea of electron and positively charged sodium ion form metallic bonding. All right, so if in the exam they ask what is mean by delocalized electron, the delocalized electron means the electron that move freely and not owned by any atom or ion. All right, so the sea of electron form when the valence shell of metal atom overlap, resulting in electron delocalization. All right, so to answer this question before we move on to the next part. All right, so what is mean by metallic bonding? So please remember the metallic bonding, the attraction forces. What is the attraction forces? Electrostatic attraction forces between the sea of electrons and the positively charged metal ion. So we try to answer this question. A bond form involving transfer of electron, this is ionic bonding. A bond form where the share pair of electron comes from one atom, this is dative bonding. We try to check a bond form involving electrostatic attraction forces between sea of electron and positively charged metal ion, so the answer will be C. All right, so we move on to the application of hydrogen bonding. All right, so we check question number 12. The diagram below shows a group of students reviewing a chemistry lesson. They found that problem turning the pages of the book where the page stick together. So based on the knowledge of the chemical bonding, how to overcome this problem, based on the situation, how to solve this problem, so we try to wet the finger with the water before turning the pages. Alright, so please remember the paper contains cellulose. Cellulose contains hydrogen atom that are bonded to the highly electronegative oxygen atom. So cellulose C6, H will be 12, O will be 6. Alright, so this hydrogen atom is bonded together with the highly electronegative atom. Alright, so next point, the water molecule on the wet finger will form hydrogen bond with the cellulose in the paper, thus the paper will stick together. Alright, so we move on to the next question. Alright, look at this question. Which of the following compound hydrogen bond does not exist? So hydrogen bond exists in water molecule, ammonia molecule, and hydrogen fluoride molecule. So the answer will be D. Alright, so we move on to this question. Alright, finger Ahmad lick his finger to turn the pages. He noticed this method is easier to turn the pages. Okay, what type of bond involved? So please remember the type of bonding involved is hydrogen bonding. Alright, so we move on to the next question. Alright, which of the following is an example of type of chemical bonding? Okay, in daily life, wet finger to turn a book. Alright, so wet air stick together. So this will be hydrogen bonding. So the answer will be A. Alright, try to draw the electron arrangement of carbon dioxide. Please remember carbon dioxide is the example of double covalent bond, and also oxygen. And I already discussed in the please try to do practice. All right, and the dative bonding. All right, so please remember dative bonding is in hydroxonium ion and ammonium ion. So we can write another one, formation of hydrogen. Hydrogen bonding can be seen in ammonia molecule, water molecule, and hydrogen fluoride molecule. All right, so we move on to the next part. All right, try to check this structure question. All right, so when they give here R and Q, all right, so from here they are sharing the valence electron. So type of bonding involved is covalent bond. All right, covalent bond. And we try to get the electron arrangement of R. So first shell 2, so I put 2. Second shell we have 8 electrons. So second shell 8 electron. Valence shell we have 1, 2, 3, 4, 5, 6, 7. So it's 7. All right, so the R from group what? Group group 17. All right, so we go for Q. Q, the electron arrangement of atom Q, it one electron, it share one electron, therefore the electron arrangement is 1. All right, so in covalent compound, please remember type of particles that present is molecule, type of bonding is covalent bonding. All right, and compound Q R has low melting point and boiling point. Please remember covalent compound, they have low melting and boiling point. How to explain this one? Compound Q and R made up of simple covalent bond. They have low melting and boiling point. All right, so this compound R, Q and R are attracted by weaker van der Waals forces of attraction. The molecules are attracted by weaker van der Waals forces of attraction. Thus, low heat energy is required to overcome the forces of attraction. All right, so next we try to draw the electron arrangement of atom R. So we already do here. So the answer 2.8. All right, so next we try to check how to draw Q. At oxygen react with Q. All right, so Q is hydrogen to produce molecule Z. All right, draw the electron arrangement of atom molecule Z. So how to do this one? So we take the Q. So we take the Q electron arrangement 1. Oxide atom electron 2.6. All right, so the Q need one more electron to achieve stable octet arrangement. All right, oxide atom 2 need 2 electron to achieve stable octet electron arrangement. Therefore, the formula will be, we bring the 2 here, 1 here. The formula will be Q, okay, 2O. Right, this is the formula. So how to draw the electron arrangement? So we try to draw O as 2 shell. Right, so the first shell, oxygen, first shell 2 electron. So I put 2 electron here. All right, 2 electron here. All right, so we have 2 Q atoms. So I put here Q1 atom, another Q atom here. The Q as 1. Right, one shell. Here also it has one shell. Okay, so we try to check the Q will contribute 1 electron for sharing. 1 electron for sharing. So I put Q will contribute 1 electron for sharing. This one also will contribute 1 electron for sharing. All right, so then O will also, oxide atom also will share 1 electron for sharing. It will share 1 electron for sharing. The oxide atom already share 2 electron. So outside of valence shell of oxide, we take 6 minus 2, we put 4 here. So we put 1, 2, 3, 4. So that's how we draw the electron arrangement of Q2O. Alright, so next we try to check this one. There's a two type of molecular structural for covalent compound. One is simple molecular structure, another one a giant covalent compound. State the differences between physical properties between the physical properties of simple and giant covalent compound. Explain the reason. Alright, so please remember simple covalent compound like carbon dioxide, water molecule. Giant covalent compound, please remember diamond or graphite, or we can use graphene also. Alright, so all this is made up of giant covalent compound. So giant covalent compound, they have high melting and boiling point. Simple covalent compound, they have low melting and boiling point. Alright, so how to explain? Okay, there is only little heat is required to overcome the weak van der Waals forces of attraction between molecule. Giant covalent compound, there is no weak van der Waals forces of attraction. Therefore, a lot of heat required to overcome strong covalent bond. Alright, so we move on to the next part. On to the next essay question. We try to check this question diagram below shows the formation of dative bonding in hydroxonium ion. Please remember H3O positive is known as hydroxonium ion. So here we have dative bonding. This hydrogen ion do not have electron in the shell. And this oxide atom is, please remember, highly electronegative atom, and it has 2 pairs of unshared electron or 2 lone pair of electron. Alright, so what is meant by dative bonding? Dative bonding is a special type of covalent bond where the electron pair that is shares comes from one atom only. Okay, is hydroxonium ion reach stable electron arrangement or not? Please check all the hydrogen atom in hydroxonium ion has achieved stable duplet electron arrangement, and oxide atom has achieved stable octet electron arrangement. So the answer yes, reach a stable electron arrangement. Based on your answer in 16.2, explain your reason. So in hydroxonium ion, oxygen atom O and all the hydrogen atom have achieved stable octet and duplet electron arrangement respectively. State another example of substance that form dative bonding. So please remember ammonium ion. Alright, so here diagram below shows the molecular formula of for compound A, covalent compound A, and compound B, and this is known as giant covalent compound. And please remember this one is known as simple covalent compound. This is known as simple covalent compound. Alright, so here state the type of covalent compound A and B, suggest example and compare the structural formula, chemical bond, melting point and boiling point. So this is A type of compound is giant covalent compound, B is simple covalent compound, example silicon dioxide, diamond or graphite also can. Alright, so here water, carbon dioxide, ammonia molecule all can. Structure, the molecular structure is very large, usually exists in solid state. The structure for the simple covalent compound structure is small, usually they exist as solid, liquid and also gases. We move on to the type of chemical bonding. So here in giant covalent compound we have covalent bond within the molecule and only the molecule only, while there is no van der Waals forces of attraction between molecule. But here we have covalent bond within the molecule and also van der Waals forces of attraction between the molecules. So here van der Waals. Alright, so and the melting point and boiling point, giant covalent compound has very high melting point, melting and boiling point. Alright, so because this more heat is required to overcome strong covalent bond between the molecule. But while the simple covalent bond, they have low melting and boiling point, they need less heat energy required to overcome the weak van der Waals forces of attraction. So on to the last part under paper 2 section C, there is an experiment to determine the electrical conductivity of ionic and covalent compound. Alright, so please check the conversation between the two students. I found the ammeter needle do not deflect when I use solid compound U is heated until melt. When Ideal said I found the ammeter needle is deflect when solid compound V is melted completely. That means this is ionic compound. Alright, and this is known as covalent compound. Alright, so how to explain this one? So we check the question, describe an experiment to show the electrical conductivity of solid compound U and compound V. In your description, include compound, example of compound U, compound V, procedure, tabulation of data, explanation, and conclusion. So we try to take the crucible. Alright, so here we have clay pipe triangle. Alright, so we put the solid compound U, we put two carbon electrode that connected to. Alright, so here we have battery, so here we have switch, then we have connected to ammeter. Alright, so we put solid. So here we put solid compound. Alright, compound U. And please remember compound U is covalent compound. So I take naphthalene, solid naphthalene. Alright, so and compound V is ionic compound. I take solid. Alright, solid lead to bromide. Lead to bromide. Alright, so we give the example. Alright, so when we use solid V, the lead to bromide, it will melt when we heat it here strongly. Alright, the solid will melt and form molten, and this molten state ionic compound can conduct electricity. Therefore, we can see the deflection of ammeter needle. While compound U, naphthalene, alright, in solid state once is melt, it do not conduct electricity because they exist as neutral molecule. So how to explain this one? The example of compound U is solid naphthalene, and example of compound V is solid lead to bromide. Alright, so we fill a crucible with the compound U solid until it are full. We put crucible with the compound U solid on the tripod stand. Alright, so we dip two carbon electrode into the compound U. Alright, this carbon electrode connected to the battery ammeter switch by using connecting wire. Heat the solid U until it melt. Observe and record the ammeter reading. Repeat step 1 until step 6 using compound V to replace compound U. Alright, so compound U is covalent compound. The ammeter needle do not deflect when the solid U completely melt. While compound V is ionic compound, the ammeter needle will deflect and will show reading when it's completely melt. So explanation, the compound V, which is lead to bromide, made up of ionic compound and exists as ion. In molten state, the lead to ion and bromide ion able to move freely and conduct electricity. While compound U, which is naphthalene, is a covalent compound made up of neutral molecule. In molten state, there is no freely moving ion to conduct electricity. Therefore, naphthalene do not conduct electricity in solid or liquid state. Conclusion, compound V can conduct electricity in molten state, while compound U do not conduct electricity in molten state. Alright, so that's all for chapter 4 and 5. So we meet up in next slot. Take care. Bye bye. See y'all.